All right, section 2.5 is about composite and inverse functions, and we're going to start with the composite functions. So you can think of a composite function as being a little bit like a scavenger hunt. You get a clue that leads you to one place, and at that place you get a new clue, which leads you to another place, and you just keep following the clues and going to a new place. So we're going to do something similar with our functions. And let's start with an example. So if we need to find the cost, C, in dollars, to paint an area A square feet, we need to know the number of gallons of paint required. So we have a couple of formulas here. We know that 1 gallon covers 250 square feet. So the number of gallons we need is a function of the area. That's A divided by 250. Okay. And then if paint is $30.50 a gallon, then we would take however many gallons we need and multiply that by the $30.50. So what we're going to do is we're going to substitute n equals f of a into g of n so we can get this cost. Right, so let's take a look at that. So C is 30.5 n. We know that n is equal to a over 250, so we can make that substitution. And if we take 30.5 and divide by 250, we're going to get 0.122a as our new function. So in other words, we now have a way of finding the cost based on our area. All right. And notationally what this looks like, we know that C is equal to G of N, that we have here. And we know that N is equal to F of A. So this is really G of F of A. Okay, so we have our functions composed, or some people call it like nested together. Okay, and this is what we're going to look at. So let's do a definition here. So for two functions, f of x and g of x, the function f of g of x is said to be a composition of f with g. If you took algebra in high school, you might have seen this notation with this little circle here. It looks something like this. Sometimes people put parentheses around that. I don't use that notation. Our textbook doesn't use that notation either. It's a bit clunky and can be difficult to discern. I think that this will be clearer, but both of these are notationally correct. All right, so picture-wise, the way that this works is we're applying a function f and a function g. So if I take f and have x as my input, I get f of x. And now if I apply g, what I have is g of f of x. Now what we're hoping to do with our composition of functions is actually to create a shortcut here. So instead of doing two little hops, we'll just do one quick trip over. And that's going to be written as f of g of x. So we'll start by looking at how to put things together using these two little hops, and then we're going to move into how can we combine this into one process. So word-wise, to explain this, the function f of g of x is defined by using the output of g as the input to f. So in other words, we always start with the inside of our function. So this part that is the most inside is g of x. So we would find g of x, and that output value we're going to plug into f. Okay. All right, so let's go ahead and we'll take a look at that in the next video.